The overall goal of this procedure is to use small-angle neutron scattering, SANS, with a shear cell sample environment to study the microstructure of complex fluids in the velocity-velocity gradient plane of shear. This is accomplished by first assembling a well-sealed shear cell sample environment. The second step is to attach the shear cell to the cell mounting bracket located on the breadboard in the sample environment stage of the neutron beamline. Next, the sample is carefully loaded into the shear cell so as to avoid air bubbles being introduced into the experimental volume. The final step is to run the experiment first by defining the shear rate at which the sample is sheared using motor control software, and second, to set up the desired SANS experiments according to the standardized SANS procedures. Ultimately, the SANS shear cell sample environment is used to measure the spatiotemporal microstructure of a shearing complex fluid. In this example, we investigate the microstructure of a surfactant solution with shear-banding flow instabilities in the velocity gradient direction of shear.
I'm Paul Butler, team leader of the Macromolecular and Microstructural Sciences team here at the NIST Center for Neutron Research. Demonstrating the experiment today will be Kate Gurnon, a graduate student in Noam Wagner's group at the University of Delaware.
Visual demonstration of this experiment is critical because there are many steps and techniques necessary in order to assemble the shear cell and load the sample. Once the shear cell is placed onto the beamline, complex fluids can be interrogated under shear flow using small-angle neutron scattering.
The first step after fabricating the parts is to assemble the shear.